പാർവതി എന്നെ കേൾക്കാവോ? ഞാൻ ഓഡിബിൾ ആണോ? ഹലോ.
അരുൺ ഒന്നുകൂടെ സംസാരിക്കാമോ?
ഞാൻ ഓഡിബിൾ ആണോ? ക്ലിയർ ആണോ എന്റെ വോയിസ്?
ക്ലിയർ ആണ് അരുൺ.
ലൈറ്റിങ്ങിന്റെ ഒരു പ്രശ്നമുണ്ടല്ലേ? ഓക്കെ, എന്നിട്ട് ഞാനൊന്ന് ലൈറ്റ് ഒന്ന് അഡ്ജസ്റ്റ് ചെയ്ത് നോക്കട്ടെ. വീഡിയോ ഇപ്പൊ എങ്ങനെയാ, ക്ലിയർ ആണോ?
ഓക്കെ ആണ് അരുൺ.
ഓക്കെ ഓക്കെ ഫൈൻ. പാർവതി,
പറഞ്ഞോളൂ.
ഹോസ്റ്റ് ആക്കുമ്പോൾ വീഡിയോ ഓൺ ചെയ്യാത്ത അരുൺ വി എടുത്ത് ഹോസ്റ്റ് ആക്കണം കേട്ടോ. കാരണം ഇത് ഞാനിപ്പോൾ സംസാരിക്കുന്ന എൻ്റെ ഫോണിൽ നിന്നാണ്, മറ്റേതിലെ ക്യാമറ നല്ലതല്ലാത്തതുകൊണ്ട് അതൊന്ന് ശ്രദ്ധിച്ചാൽ മതിയേ. ഓക്കെ.
വീഡിയോ ഓൺ അല്ലാത്ത അരുണിനെ ഹോസ്റ്റ് ചെയ്യാനായിട്ട്.
യെസ് യെസ് യെസ്, അതിൻ്റെ സിസ്റ്റമാണ്. ഓക്കെ.
Arun കേൾക്കാമോ?
Yes, sir. You are audible.
Thank you.
Good evening, sir.
Good evening, Arun. Can I just flash my screen if you can just confirm?
Yeah, you can turn on your camera.
Oh, okay. Is it visible or is it dark?
Yeah, you are visible, but a little bit light would be useful. So കുറച്ചുകൂടെ light ഉണ്ടെങ്കിൽ
ഒരു സെക്കൻഡ്. Is that clear? Better, I
yes,
think.
sir. Yes, sir.
Okay. Okay. So I'll stop it for now. Share enabled അല്ലേ?
സാർ അത് മീറ്റിംഗ് സ്റ്റാർട്ട് ചെയ്യുന്ന സമയത്ത് സാറിനെ പ്രസന്റർ ആക്കാൻ സാർ.
ഓക്കെ.
സാർ ഇപ്പോൾ പ്രസന്റർ ആയിട്ടുണ്ട്.
സാർ ഒന്ന് ട്രൈ ചെയ്തോളൂ, PPT ഒന്ന് ജസ്റ്റ് പ്രസന്റ് ചെയ്ത് നോക്കൂ.
ഷുവർ ആയിട്ട്. വിസിബിൾ ആണോ?
സർ വിസിബിൾ ആണ്.
Yes, sir.
ഓക്കെ. ഓക്കെ.
സ്ക്രീൻ ആണ് വിസിബിൾ ആയിട്ടുള്ളത്, PPT കാണുന്നില്ല.
PPT ഞാനിവിടെ തുറന്നു വെച്ചിട്ടുണ്ട്. ഫുൾ സ്ക്രീൻ ആക്കാം. So for now I will stop sharing. Okay. തുടങ്ങാറാകുമ്പോൾ പറഞ്ഞാൽ മതി.
Okay, sir.
Arun, can you confirm if there is any background noise from here?
No, sir. I think your voice is very clear.
Thank you.
Bridget, sir?
Yeah. Shall we start?
Yeah, we can start, sir.
Okay. Let me share my screen.
Sir, let me introduce you.
Sure. Definitely.
A warm good evening to everyone. Welcome to our online session on Grab Your Dream Job in Business Analytics. Today, we have Sri Brijesh Madhavan as our guest, who is going to enlighten us on the career opportunities in business analytics job sector. Sri Brijesh Madhavan is the CEO and founder of CurveLogic's Advanced Technology Solutions Private Limited and a co-founder of Genobiosis Computational Genomics Labs. His focus is to grow CurveLogix into a successful artificial intelligence company through cutting-edge R&D and developing AI product lines centered around robotics, Internet of Things, blockchain, genomics, big data, and advanced analytics. Over his 23 years of experience in advanced statistical modeling and machine learning, he has held senior leadership roles heading advanced analytics, big data, and artificial intelligence teams in MNCs such as HP, IHS, and EY. Sri Brijesh Madhavan, we welcome you to our session.
Thank you, Arun. I think we'll get started, isn't it? Okay, so like Arun mentioned, let me just start with a couple of sentences about me and my organization, right? So I head CurveLogix. We are a pure play AI, machine learning, and advanced analytics company, right? So we'll also talk about at a later point in time how these are all connected and how they all overlap a lot, right? So we'll be talking about that as well. And so we are primarily some of the founders, including me, right, have had a long stint of time that we spent in academia, in organizations like Indian Institute of Science and so on, right, working on things ranging from question of organisms to climate change and many, many things like that. And I moved on to companies like HP, which were the early adopters of advanced analytics. When you're talking about advanced analytics, I'll tell you what advanced analytics is in some time, right? So just after my PhD and postdoctoral research, I was looking for a corporate job. First job was with Hewlett-Packard, HP as the laptop manufacturer and server manufacturer, right? And then I moved into a company called IHS, which is into aerospace, defense, maritime, and all of that, oil and gas, right? And all of that. And then I came down to Kerala, joined Ernst & Young. I led the AI and advanced analytics team. I actually created the AI and advanced analytics team in Ernst & Young. And now it is part of something called the DNA team, right? Data analytics team. And so that's why anything that we do has this connection, right? So we are primarily AI, ML, predictive modeling or predictive analytics people, right? And then because of the research and academic stint, right, we've always had this going together, right? So, and that's also the reason, right, we as an organization have always worked with academic institutions or government bodies like ASAP, right? So in creating a local ecosystem here, you all know that Kerala has amazingly brilliant people. There is opportunities that are increasing immensely here, but probably we don't have the right skills, and that's why organizations like ASAP was brought in, right, by the Kerala government, right? And they're doing phenomenally well. We work closely with them on, delivering courses and so on, right? And that's my background. Otherwise, the company, like I mentioned, is into AI, ML, predictive analytics. We also mentor early stage startups, which means that we have a fair amount of connects a network here, right? In terms of startups, MNCs, and so on, right? So we provide technology consulting and so on. Right? And so now that was about me. That was about my organization. Let me not spend more time on that. If anybody is interested, you could go on to look at curvelogix.com. But coming to the point of the webinar today, right? It is about analytics, right? Specifically business analytics, right? So if you look at analytics, it has been there for really, really long, right? So if you look at how India actually got into the IT landscape, right? About 35 years, we had a lot of people from India being hired in the US. You had, if you look at the top leaders there, right? Many of them went 20, 25 years back, like Sundar Pichai and all of them as well, right? Are in that big list of people who were people who moved to the US, were doing phenomenally good things on the software development and so on. Right? That's when everything, if you look at it, let me take an example, right? So let me take an example of banks, right? I'm about 46 years old, right? And as a child, when I used to accompany my dad to the bank, right? He would write a check. He will give it to the clerk in the bank, right? You know what the clerk in the bank would do. Many of you, probably people of your age, if you're specifically someone who's just finished your BTech or you know, in any of the graduations, graduation degrees, right? You probably are not in that age group where you would have seen the kind of activity that I'm going to talk about, right? So, for example, when I was a kid, when I went to the banks with my dad, when a check was written, right, the clerk would actually take this check, go on to refer a big fat books where details of my dad's account was there, right? He will check and he'll see what is the balance, right? And then what is the amount is the amount that is requested, you know, that can be actually given to the customer, right? And if once it's given, they will go and add some numbers there, right? So they will say, okay, subtract, let's say 5,000 rupees, because the check had 5,000 rupees, subtract 5,000 rupees, right? It was manually done with paper and pen, right? And I'm not talking about a very old time. I'm talking about, you know, people of my age, a lot of your parents' age, people have seen this, right? And then by the time I, you know, went to college, things had all changed. Right? Things had started becoming digital, right? A lot of bank-related stuff started getting automated, right? Banks were starting to have computers, right? And what was done in pen and paper now was being entered digitally, right? When you could enter digitally, right? Unlike the physical books where accounts were maintained, that you could actually share, you could transmit over network, right? So transmit over network would mean, right? If SBI is there, if it had like thousands of branches, anybody in SBI could access the data of my dad, you know, if they are connected to this large network, right? If all the machines are connected, if there is a bunch of servers there that would host all of this, anybody from any corner could actually access that, right? Which means that my dad could actually withdraw money from, let's say I was brought up in Nilgiris, Ooty, right? From there, or when he goes to Bombay or Delhi, he could also withdraw from there, right? That's what we call core banking nowadays, right? So that happened, right? And what happened? Digitization happened, right? Digitization created what? This thing that you see here, information explosion, right? The amount of data that was generated didn't reside in books, right? Not in accounting books, in physical form, like paper, right? Now it was all digitized and were available as data that was easily accessible, easily analyzable, right? So it is as old as 30, 35 years, people have been talking about, you know, taking data, doing analysis, but at that time it was not called analytics. It used to be called business intelligence, for example, or it used to be called MIS, right? Management information systems, where what was used basically for managing, you know, for the management to take certain kind of decisions. They would actually go on to access data, summarize them, etc., right? For example, SBI wanted to know what is the total amount that was deposited in a particular day, right? They could just go on to query from a database, right, where all this data is actually stored in databases, and then they could get at the end of the day, right, all the branches together, right? What was the amount that was deposited, right? And they could do that, and that those used to be called, those kind of analysis used to be called, you know, business intelligence, right? And over the time, business intelligence started getting a little different name, right? Business intelligence, MIS reporting, all of that slowly started getting a little different name, right? So now it was, like I mentioned, you know, organizations like SBI or any of these large railways, all of them who have huge amount of data, they could summarize it, they could see it as numbers and tables, but it didn't stop with that, right? When looking at numbers and tables, if it is millions and millions of record, sometimes it's difficult to make decisions, right? People went on to do visualization, right? Put graphs, charts, and all of it. Make it easy for decision makers, right? To they look at numbers, they look at charts, they look at graphs, and all of that, and quickly they are able to understand what is going on, and then they could make decisions, right? So this was typically called business intelligence. It could be within the organization, it could be the competitor information along with your data, and all of those kind of things, right? And around the time, right, around like 15 years back, right, actually around 10, 12 years back, that business intelligence started having a little different name, right? And it was called analytics, right? So anything analysis, anything that gives some intelligence that is to do with the business, right, was called analytics. So, and so all of this started with information explosion. And how did the information explosion happen? It happened because a lot of data was digitized. It was not in paper and pencil. A lot of business activities were captured in computers. It could be shared over network, right? And that's how it started, right? And so this rest of what you see here is are other aspects that kind of got analytics to be a core function in any organization, right? Any organization, small or big, right, can't do normal business without analytics, right? So if you 10 years back, if you asked any company, hey, do you have analytics wing? Probably not. Today, you ask any MNC, a mid-sized company, they would say, yes, we have a dedicated analytics team. And what do the analytics team people do? It could be summarizing data, like I mentioned, right? It could be Excel, it could be SQL databases, where all this data is captured, right? And summarized and visualized as graphs and charts online. It could be interactive, a CEO or a CTO or any of them could actually go on to interact, drag, drop, select date like in your calendars, right? And then they could see the summary, right? So those kind of things were happening, right? And with advancement in technology, right? So again, like 20, 30 years back, only information that people thought was important was saved, right? Over the time, something else happened, right? The cost of computation became cheap. The cost of storage, means your hard disk cost and all of that, we'll come to that in some time, right? Started becoming cheaper, right? Which means people decided not to throw away any data that is generated, right? You store it, and then you're going to analyze it. You're going to store. It's not just one set of data, but hundreds and hundreds of different sets of data. That is all that all can be interconnected, right? For a bank like SBI, for example, it's not only who withdrew, who deposited, right? It could be a lot more, right? At what time did people deposit money, right? In a particular bank, right? What is that peak load? Are the clerks having difficulty? Are the people who are in certain counters having overload, right? Should additional staff be added, right? Suddenly it doesn't stop with money and all of that. It also starts with, how you manage your staffs, right? What is the best? Should you start a new branch, right? Or if it is ATM, if the amount of money that is being withdrawn is phenomenally high, right? Should you deposit or should you replenish the amount in an ATM machine, right? And all of that is based on analytics, right? So that's some examples. So advancement in technology led to many things that could be done, which was not possible some time back. In terms of technology, could be algorithms. It could be physical devices like very fast computers, very cheap storage, right, and all of that, right? And then things like AI, ML, all of them also crept in. We'll talk about how AI, ML in some way overlaps with analytics as well, right? And so what is happening nowadays? Some of you would have heard of the fourth industrial revolution, right? They say that we are in the fourth industrial revolution, right? So if you look at the past, right, what was the primary source of income for people long back, hundreds of years back? It used to be farming, right? People used to grow cattle, people used to grow crops. They would go and sell, and then they would make money, right? Someone would weave cloths, someone would cut hair, do all those kind of things. Those were the means of money, right? And over the time, suddenly all of this many of these got automated, right? Farming was heavily machine driven, right? Weaving cloths was heavily machine driven, right? Building cars was heavily machine driven, right? All of that started happening, right? A lot of it with steam engines and then diesel engines and gasoline engines and all of them coming in, right? A lot of work started getting automated, and that's what we call the industrial revolution, isn't it? So they say that we are in the fourth industrial revolution, right? Where if you look at the previous IT industry, so like 10 years back or 5-6 years back, what the IT industry was doing is what I just mentioned some time back, right? Take data, summarize them, have software which will read, retrieve, make entries into the database and so on, right? A lot of applications were around those kind of things, right? Today, we're talking about things that are intelligent, right? It is analytics backed, right? It is software that can help in, making decisions faster, not just by giving numbers, but also saying that, hey, you know what, it looks like the revenue of this company has been dipping, and the reason for that is a competition, right? Or the demand for the product is reducing in the market and so on, right? So it could go beyond just giving numbers, but it could give us very meaningful insights, right? So, so whatever I've talked now is actually summarized in this chart. This is a chart by an organization called Gartner, right? For some of you who are fresh out of college, you might not have heard this name, but Gartner is one of the largest market research firm focused primarily on technology landscape and technology, latest emerging technologies and all of that, right? So they market research firm, they put out research reports, which kind of talks about what is that, what is the trends in certain kind of, technologies, right? What is the emerging trend that would disrupt and so on, right? They put out hundreds of reports every year. Everybody, including Google's and Microsoft of the world, actually go by that report. They have that kind of reputation, right? And this is a report that Gartner had put out 10 plus years back, right? So this is a screenshot from one of those reports, right? And what does it say, right? So this is what they visualized, right? So what is that they visualized? They have visualized different types of analytics that is there, right? Sometime back, I talked about SBI, right? Where data from many branches are all summarized and so on, right? And those kind of things are called descriptive analytics, right? And so which is basically summarizing data, right? They're called descriptive analytics. And what does it give? It gives what happened, right? What happened, like SBI end of, November 3rd, 2021, what is the amount that was deposited on that particular day, right? So that is what happened. Right? That's an example that I gave, right? So like that for any business, right? If it was CurveLogix in the month of November or in the month of October, how much revenue did we make, right? That is that is actually captured somewhere in the databases, and we summarize that, and then we get to know, right? If I were to run a business, I need to know all of that, right? So the finance team would actually tell me, hey, but this much is the amount that is collected, right? And that is descriptive analytics, right? Summarizing data and trying to understand what just happened, right? That is descriptive analytics. It's called hindsight, something that happened in the past, right? It's called hindsight, right? And then there is a more advanced form of analytics. It's called diagnostic analytics. Why did certain things happen, right? If let's say CurveLogix, or let me take an example of SBI. SBI, month on month, right? So October amount deposited was X million. September, the amount deposited was something else, and previous month something else, and so on. Let us say the amount deposited is growing exponentially, going very fast. Why did that happen, right? Is there a lot more cash in the market, right? Or is it that a lot of the customers who probably are working in the corporate or, or in the farming sector or something have had a lot of influx of money, and then they are all coming in. Was it a harvest season, right? Or is it a season when, companies were paying out bonuses, right? And so on, right? So why did that happen, right? A lot of it can't be just, you just can't make sense of it by just looking at, hey, you know what, September, it was 500 million, October, 510 million, right? It's also a little difficult to say, 500 versus 500 million, was it really by chance, or was there really a pattern, right? So when you take this course, right, when some of you register for this course and take it up, you will get to understand what I'm talking about, right? For now, probably it might not be easy to understand, but things like small differences that are there, right? You can't really make conclusive decisions out of it, right? Was there actually an increase, or was it just that one person or a bunch of people together by chance put up 10 million extra, and that's why the difference of 500 versus 510, right? And that needs to be proven statistically, right? Using tests called like t-test and so on, right? And those kind of analysis is called diagnostic analysis. Why did this happen? Why is it that trend that we saw, right? What is the reason for it, right? And it's called diagnostic analytics, right? And that portion is also called, it's primarily to do with drawing insights. You have the data, you're trying to draw meaningful information from that, right? Based on which you could actually make decisions. And then there's the next level, right? Which is called foresight. Hey, all this is happening. What is going to happen in the future? 5 months later, what would be the amount of money that is deposited on a particular month, right? For SBI, right? For all the customers, when they put the money overall, what is that amount that is going to be there? Let us say, March of 2022, right? And so on, right? So that is about forecasting what is going to happen in the future, right? And that's called foresight, or that particular component is called predictive analytics. And this is where AI, ML, all of them overlap, right? So for predictive analytics, you typically use something called statistical modeling, right? Or machine learning, right? And machine learning is a large part of artificial intelligence, right? So in this course that you're going to have, you're going to be looking at all of these things, right? Descriptive analytics, diagnostic analytics, predictive analytics, and to a great extent, something called optimization, right? Which is called prescriptive analytics, right? Given that in the future, certain kind of events are likely to happen, or, like the SBI example that I said, it's in the month of March, the revenue is going to be this much million, right? And should we run some campaigns? Should we, reduce our interest, etc., to make it even better, right? And that is called prescriptive analytics. Where have you all heard prescribe, the prescription, etc., right? You've heard the doctors prescribing medicine, right? So the business analytics team, the data science team, people with those kind of analytics background actually would prescribe, probable actions that needs to be taken, right? And that's why it's called prescriptive analytics, right? So starting with what happened, why it happened, right? What is likely to happen in the future, right? And what should be done to make things even better, right? And that's prescriptive analytics. So and that particular part is called optimization, right? And this is a very famous chart that Gartner has put out. I think it kind of captures all of what would typically be done in analytics organization, right? And for achieving all of this, there are like dozens and dozens of tools, dozens of algorithms, and so on, right? And this course that we're talking about, right, would cover a lot of it, right? I've been working with ASAP, the panel that actually set up this syllabus had people with really, I'm sure, like, if all the panel members' experience was added, it would be close to 100+ years, right? We had people from IIT Palakkad, we had people from Microsoft, we had people from some of the large MNCs here, right? I myself was part of it as well, right? So all of them with like 20-25 years of experience, right? Put together, I'm sure it's upwards of 100+ years of experience, right? So that's what it is, right? And they've all contributed to this in different ways. They all have expertise across all of these, right? And I think this is one of the most wonderful course in this and the curriculum, right? So now let me skip all of this. This is definition of predictive analytics. I'm going to skip that. You kind of got a fair idea of what it is. So I talked about descriptive analytics, right? Prescriptive analytics is, like I said, it's about summarizing data and all of it. But then the amount of data that is out there with each of these companies are humongous, right? And for that, right, by just looking at tables and charts can be overwhelming, right? It could be a little confusing, right? And people have started using visualization tools, right? Like what you see in this chart, right? You can see all of this at one shot. There's so much information out there, right? I'm sure you've been following what's happening in the state from the time the COVID pandemic started. I'm sure you've gotten to see in YouTube videos and things like that. Kerala has its COVID war room, right? And then they have like big screens that has data flowing in real time, right? And those screens have visualizations like this, right? And that's analytics. The government is using advanced analytics to figure out what's happening in the state, right? To make decisions, right? And so on, right? And so that those are some examples. This when I say visualization, it's about charts and graphs and all of them, right? Display like what you see here, right? And in this course, you will get to see a lot of tools that are meant for visualization, right? Predictive analytics. Let me skip this before I skip this. So typically, the data that we would use in analysis would be numbers. You can see this. You know, there's something to do with country. There are some salespeople's name. There is dates there, and order ID, units, etc., etc. Some sales data is what is there, right? And that has been visualized as something called a line chart, right? And it has a time dimension here, and it's called time series data, right? And you would actually do a time series forecast to predict what is in the future, right? So our data and analysis only to do with this kind of data, right? Excel, SQL kind of data. But that's not true, right? 15 years back, it was the scenario, right? Now it's very, very different, right? With Facebooks and Twitters and Instagrams of the world, putting out a lot of this content. When, let's say, some of you, when you're really upset with a particular organization, right? You boarded a flight and the flight service was bad. The moment you get out of your flight, you know, in the airport itself, you would tweet saying that, hey, I had a terrible flight experience, right? And those kind of things are actually meaningful information for that company that is running the airline, that particular flight, isn't it? So data is not just sales data like this, right? It's not just tables and Excels, tables and databases or Excel sheets and things like that. It's way beyond that. Data coming in from Twitter is so important, right? You need to know how your company is performing, right? How do the customer feel about your organization, right? And where can you get that? You can get it from social media, right? It could be text, right? It could be audio, video, right? Somebody is having a YouTube video created, right? And if there are thousands and thousands of them, you can't have an army of people sitting and listening to that and, you know, drawing insights from that. It should be automated, isn't it? So the data that I'm talking about is not just Excel sheet or not just what is in SQL servers, right? It is images, videos, audio, email, right? If you look at my email box, it's about 15 GB, right? If I were to read through all of those, right? Or if I had to search through it, it's very, very difficult, right? But we have certain tools that actually will crunch all of my email, right? And it could actually give me in the past, right, whom all I had great interactions with, right? Who are those businesses whom we had positive discussions? I could actually do all of that, right? With really good analytics tools and techniques, right? So emails, streaming social media, content like Twitter data, right? audio, video. So for example, somebody's put out a YouTube video, or there is a news channel that is putting out videos, and you want to get to know at any point in time if your company is actually being referenced in some news channel, right? Can somebody sit and watch that continuously? Very difficult, right? It's going to be very expensive. Can machines do that? Machines can do that nowadays, right? So the data is not just Excel. It could be plain text, large logs of data, right? Conversation of customers, for example. You have a customer support team, and then they are conversing. That could actually be that itself could be a useful set of data, to gauge customer sentiments and so on. It could be internally, it could be a bunch of servers that are running, and then it's throwing out errors and so on, right? That is meaningful data, but they're all generated in terabytes, right? Mining through that, sifting through that by a technical person could be humongously tedious. Can the machines do that? Machines can do that, right? And they are not tables; they are just plain text, right? And so those kind of things. There are like hundreds of resumes that are coming in, let's say, right? Can machines parse that and get details like, hey, who are the people with the right skills, and so on, right? For small organizations, okay, but if it's thousands and thousands of resume coming in, right, you really can't have hundreds of people sifting through that. But can machines do that? Nowadays, machines do that, right? So data is not just Excel. It could be PDF documents, it could be images, it could be videos, it could be audio, and all sorts of things, right? Now, so that's what the data is now, right? So compared to 30 years back, or compared to 15 years back, things have changed, right? And we'll also come to the details why it has changed, right? One of the reasons definitely is social media, right? Like Facebook, Googles of the world, putting out, a lot of applications that customers use. Twitter and many other things, right? So we'll come to that point, why that is all, why there has been an information explosion, and how these companies emerge to be contributing to that information explosion, right? And so otherwise, right, traditionally, right, where was analytics being used, right? When I started my career, right, with HP, there were only very few companies which was actually doing advanced analytics, right? The HPs, the IBMs, and the Cisco's and Dell's of the world, right? All the big tech companies then, right? At the time, we're talking about Apple and others not being as big as these organizations, right? So now it's all changed, right? Apple is the biggest tech company, one of the biggest tech companies, right? And or it was the banks, right? And why were the banks using it? Banks was using it because, let's say, there is credit card and credit card fraud that is happening. Right? That's a big costly affair for them. Any kind of fraud, for example, is very costly affair for them. Or they're giving out loans to customers, and they need to predict if the customer can actually pay back the loan, right? And they were using predictive analytics. This is way back 20 years back, right? So the banks and the technology companies were primarily using it, right? And what were they using it? They were using it for sales and marketing. They were using it for human resource, supply chain, finance, etc., right? Is that the only area where analytics is being put to use? No. Today, everywhere, right? There won't be a division that is not generating data, and the data is usually humongous. We are talking about within a company. Right? Within a company, you have the finance divisions, you have the accounting divisions, you have HR division, you have the tech support division. All of them, right, generate massive amount of data, right? And to see if a company is going the right path, or to make decisions on expansion of the team and many other things, right? Analyzing the data is so important, right? So that's what I've summarized here, right? So almost everywhere, right, analytics is such an important thing. It is like, so I keep telling my students, my staffs, right, 30 years back, if you go on to sell a computer to a textile organization, they will chase you out. They'll say, I don't need a computer, I have book and pen, right? I will keep all of my accounts there. Today, you go to a pawn shop, that guy keeps accounts in his mobile phone. He does transaction with GPay, right? He has quick access to what he has collected, right? So analytics has the same impact, like how computer has had in any kind of business, right? So today, without analytics, people can't run their businesses. That's how it has happened. So it's such an important thing. Okay. And okay. So by the way, analytics, like I said, has been there for really long. It just had a little different name. It has been there from the 70s and the 80s, etc. Right? People were doing something like credit card scoring, fraud detection, and all of that. Definitely in the 90s and the early 2000s, and that it has been there for a while, right? But what has changed, right? This is what has changed. By the way, this is my little daughter that you see here, right? A few years back, right? And what she has in her hand is a small computer. It's called Raspberry Pi. Many of you with electronics or computer science background would have already seen that. It's a credit card size computer, right? And what is special about that, right? That whole computer costs only $35 at that time. Now it's much cheaper, right? So we're talking about like, I think 7 years back, right? 5 years back. So yeah, around 6 years back, right? It used to cost $35, right? And what was it weighing? It was weighing 45 grams, right? And what was its power? It was 20 times faster than a supercomputer that was the best of the supercomputers in the world in the 1980s, right? And we're talking about $35 compared to what? $10 million. In the 1980s, a computer that was only 1/20th of the speed of a Raspberry Pi, right? Which the Raspberry Pi is only of this size, right? A credit card size, right? It costs today $35, right? So I talked about technology advancement, right? The whole thing about the technology advancement is one of the core things is this, right? Computation has become cheap. Storage has become cheap. What she's holding actually has a 32 GB storage card, right? Which weighs how much? 45 grams. Let us compare it to what it was several years back, right? In the 1956, right? IBM had some of the fastest machines, and the Mac 305 is what it's called, right? You can see adult here, right? And the back, you see this large black cylinder within this glass, cupboard kind of thing, right? That black cylinder was the hard disk. And what did it store? It would store 5 MB of data. Today, when you click a picture with a high resolution camera, it's upwards of 16 MB. One picture, right? They had all of the data that is required for companies stored in like 5 MB. And what did it cost? It cost $50,000, right? And that is the kind of change that has happened, right? So think of hard disk that is 32 GB. Today you probably would not even get a 32 GB SD card, right? Everything is upwards of 64 GB and so on, right? And it weighs 45 grams. It costs 200 rupees, right? Couple of dollars, right? And that's what it is compared to this, right? So the price of computation and storage has significantly come down, right? And that's why if price of this is price of computation and storage has come down. Storage means like storing data. Where do you store it? You store it in hard disk, you store it in SD cards, you store it in all sorts of tapes and so on, right? And that cost has come down, right? So, and because it cost has come down, there are newer companies that has emerged. What kind of companies? YouTube, Google, right? Imagine Google would not have been here if the computation cost or the storage cost was not cheap. At the time when Larry Page and Sergey Brin set up the company, right? They went on to put desktop computers together, right? They put many desktop computers together and connected them, right? And desktop computers were cheap at the time, right? And that's how Google emerged, right? Because the computation at that point in time was cheaper, right? YouTube, for the same reason, storing videos requires huge amount of data, storage space, right? This was practical, right? They would let you use, nowadays videos can be like 6 hours long or 4 hours long, right? They would let you upload it free of cost. right? And yet they would make money out of it because advertising cost is much higher, or people pay for advertisement more than the storage cost, right? The storage and computation cost is much cheaper compared to showing few advertisements, right? And that's how YouTube's business is, right? Same thing with any of these companies that you see here, right? Pinterest, Twitter, Facebook, Netflix, all of them, right? They're all there because they can host huge amount of data, right? And the reason for that is cost has come down, right? And that's why now when you have huge amount of data, what is important? Humans can't sit and read and make sense of it, right? You need tools and techniques to analyze it, and that's what analytics is. That's what business analytics is all about. So that's why they call data as the new oil, right? Every company that you see are focused on gathering data. Facebook's, Twitter's, Google's, everybody gathers data. Any company that gathers data is rich today, right? So data is the new oil. If that is the case, right, some of the best of the companies is focused on gathering data, which means analysis of that is important. And that's why this course is such an important thing, right? So I'm going to skip this. I'm not sure if we have enough time. Arun, do we have enough time? What is it like 7:51? How much time do we have, Arun? Can we go on?
Sir, we have 10 more minutes.
10 minutes. So let me just finish up a few more things.
Okay, sir. So this chart is a very famous chart, right? And it's about the rate at which things are changing, right? So the kind of tools that we were using in analytics sometime back, 15, 20 years back, is very different from what we use today, right? Why? Every year after year, machines are able to do heavy lifting, right? They can solve problems that couldn't be done 5 years back, 10 years back, right? It could be done, but it was ridiculously expensive, right? Because you needed a lot more computation. But, year after year, right? That cost of computation is decreasing. How is it decreasing? It is decreasing exponentially, not linearly, right? The cost is not coming down. So the computation power is increasing year after year, right? Exponentially. Like many of you would have heard this law called Moore's law, right? Moore is one of the key executives in Intel, right? When they were making chips, they realized that every 18 months, the processor speed could be doubled, right? If processing speed doubled, the cost can actually come down by half, right? If that happened over the year, right? Year after year, right? Year after year, it is going to keep coming down, right? The growth in technology that is computation intensive suddenly starts becoming better, right? What couldn't be done 5 years back can be done now at very low cost. The phones that you use is way powerful than all of the computation resource that Bill Clinton had. The most powerful person in the planet is considered the US president, right? So they say that the phone that you used, and the saying was there 5 years back, by the way, 5 years back, right? At that time itself, mobile phones were as powerful or way more powerful than what Bill Clinton had. So what Bill Clinton could get as intelligence, right? Like he could quickly get information from his intelligence department, right? You could actually get a lot of it from tools like Google, right? And that's why they say that the phones that you hold is way more powerful than what the world's most powerful person had access to when he was a president, right? So that's how it is, right? And how did that happen, right? Year after year, computation becomes so cheap that what was accessible only to the big IT companies or very powerful people, right, started creeping into your phones, right? Creeping into devices that you are starting to use, right? So, and that's the whole thing about, exponential growth, right? And AI, analytics, all of them are
are emerging to be very, very powerful because of the same reason, right? And by the way, where are we? Right? This is more. This chart is more to do with AI or something to do with machine learning and all of that. Part of this course is not AI course, right? But there is a overlap with some of the techniques, right? For example, there's some predictive analytics involved, right? In the business analytics course, right? And that has a major overlap with AI. Right? So this course is not AI. ASAP has a separate AI course as well, right? But this is business analysis course, but then there are components that overlaps, right? And I'm going to skip all of this, right? So machines have become smarter, intelligent, etc. Right? So these are some examples, right? Machines have become smart, and it's all centered around data, right? In this particular picture that you see is something called Jeopardy, a game, a reality show, right? In the US, right? Where many participants together, compete to answer quizzes, right? You can see the central participant is a machine, right? It's called IBM Watson, right? And this happened not now, 10 years back, right? And it won the $1 million award. And it competed, it beat humans, the closest humans who were participating in that won $300,000, right? So the machine went on to finish the reality show much earlier, way smarter than human, right? So and it's all to do with data. It was not connected to the internet. It had 50, I think, like several dozens of hard disks, and it had terabytes of data in it. It had information from Wikipedia, etc., right? And it could understand voice. It could the person who was running the show would actually just ask natural language questions, right? He would just ask questions like he would ask humans, right? And the machine would answer, right? So that's where it is happening, and it's all centered around data, right? Machines can see better than humans nowadays. 2015, somebody from Stanford actually went on to do certain analysis, and they realized that machines are able to see better than humans, right? In 2016, Google built AI engine, right, which could actually beat the world's best champion in a game called Go. Go is considered to be way far complicated than chess. It's a Chinese game, right? It's considered way far complicated than chess. And what does it have? It has, like, they say that the number of atoms that are in the universe, right, equal to that is the number of moves in the game of Go, which means that a human can't just make rules and then the game is just not driven by rules. Right? You can't just sheer computation is not enough, right? You have to have smarter algorithms, right? Again, centered around data, machines learning from the data, and so on, right? And there are so many other examples. I'm going to skip all of this, right? So this is the hype cycle. You'll see a lot of technologies. So this is, again, the company that I mentioned sometime back, Gartner, right, who publishes reports, right? The same company has puts out a particular type of graph called the Gartner's hype cycle, right? Where different technologies that are emerging are shown here, right? So they say that any technology that comes in first initially has very low adoption, right? Over the time, people talk about it way beyond its actual utility. It gets into the hype phase, right? And then people realize that some of that the technology can't actually do certain things as people claim, right? And then over the time, right, it gets to a level where people have a clear understanding of what the technology can do and what it can deliver, right? And it's called the Gartner hype cycle. Most technologies actually go through this cycle, right? And you can see many of them that are there, all of the IoT platforms, et cetera, right? All of them are having data core to it, right? And I'm going to skip this. So I think so what is the future, right? We're talking about we talked about prescriptive analytics, and prescriptive analytics is typically to do with algorithms, right? Although I've used AI here, right? Both of them, like I said, has major overlap. Like we're going to see in the future, like I said, in the 90s, in the 2000s, banks were using algorithms to detect, they were doing predictive analytics to detect which of the customers are risky customers, right? The technology has emerged so well that they can actually do simulations, and with a couple of moves, right, of a customer, they could actually detect way ahead of time, right? Not detect when a fraud has happened, way ahead of time, they would realize that a fraud is likely to happen, like in the movies, like Minority Report or other movies that you might have seen, right? Very similar to that, right? So it's going to be more around preemptive fraud detection, or the same thing is applicable in network related penetrations and hacking and all of that, right? People will be able to predict ahead of time. They can actually prevent a hacking attack. They could actually prevent, to a great extent, fraud that is likely to happen and all of that. So that's where the world is going, right? I'm going to skip all of this. Analytics is considered to be core to, things that are to do with stock market predictions and things around wealth management and so on, right? I think I will stop with it. I'm going to skip all of this. I think I will stop here. Probably we should open it for questions then. Can you hear me?
Yes, sir. Thank you for that session. ASAP Kerala is offering business analytics course in online mode with certification from IIT Palakkad in association with Curve Logics. Bridger sir, could you just elaborate what we are covering in that course a little bit?
Yeah, absolutely. So I don't have a slide around that.
No.
But what we are going to do is, like I talked about some time back, right? The course has been very well structured, right? It's going to have all of what I mentioned, all the components that I mentioned, right? From handling data from a database or using tools like Excel, right? To visualizing, right? Using tools like Power BI and all those kind of different visualization tools, right? To going and doing statistical analysis, right? All sorts of analysis, that is things like t-tests and so on, right? For that, you need to understand basic things like probabilities and so things that you learned in your high school or during your graduation, right? Some of that would be recapped. We will go a little more advanced beyond what probably you would have learned, unless you are a statistician or a mathematics major. You have a master's in mathematics, right? So we'll be covering things around probabilities. We'll be talking about random numbers and many other things, right? And which eventually will lead to using algorithms, machine learning algorithms, and so on, right? And to a great extent, prescriptive analytics, right? So the course is going to be it's a very elaborate course. It touches upon all of these different components, right? So prescriptive analytics, diagnostic analytics, predictive analytics, and great extent prescriptive analytics. Besides that, right, there are domain-specific, modules as well, right? So things that are more to do with marketing, right? Things that are associated with economics and finance, right? Those kind of functional aspects are also going to be part of this, right? So the course has been structured in such a way, it's not just about technology, right? Aspects that are to do with business is also covered, right? So things around supply chain, for example, right? There are specific kind of analytics that are to do with supply chain, things that are to do with sales and marketing, right? There are a whole lot of analytics that is centered around sales and marketing, right? So there are modules that are of that type, right? So, and there are optionals that you could actually pick and choose, right? When it comes to a business specific or functional aspect of the course, right? The technology aspect would all be common, right? But you could actually go on to pick modules that are more centered around business, right? Of things that is probably of interest to you, right? And if you're already working, this course is equally good for people who graduated from college recently, right? At the same time, people who are actually working right now, like people who are working with the data, people who are programmers, right? All of them, but then they want to actually move into analytics as a career, right? For switching the career as well. This is a apt course, and it's very elaborate, right? Is what I would summarize it. And that's it. Right? If there are any questions, please bring it up.
Okay, sir, we can start with Q&A session. We have one question. What are the common algorithms used in this domain?
So when we talk about algorithms, right, typically we talk about it in a predictive analytics side, and there are hundreds and thousands of them, right? But some of the common algorithms would be like linear regression and logistic regression and support vector machines and neural networks and so on, right? And so if you meant algorithms, so all of what we do in computer science, if you are writing programs and all of it, they're called algorithms. There's an algorithm associated with it, right? But in a AI, ML, or in a business analytics context, when people talk about algorithms, it is primarily predictive analytics algorithms or predictive modeling algorithms or machine learning algorithms, right? And the examples that I said are the common ones, right? Linear regression, logistic regression, support vector machine decision trees, neural networks, right? And so on. I hope that answered.
We have another question. From Pradeep Kumar has asked, what are the prerequisites for our course, for our business analytic course?
What I would actually recommend is, and ASAP as well, right? Somebody who has a flair for quantitative analysis, someone who likes numbers, right? That is one thing. And in this, there are also, we're also going to be exposing you to programming languages like Python and R, right? And that's become such an important thing, right? So I talked about different types of data that's going to be used, right? For analyzing that, just a click and drop kind of tool probably is not sufficient enough, right? And you need to be equipped also with tools like or programming languages like Python and R. R is a statistical programming language. Python is a language that is heavily used in predictive modeling and so on, automation and predictive modeling, right? So we'll be going through some of that, right? Besides that, there are other tools that are to do with visualization like ClickView, Power BI, and there are certain open source tools for visualization and all of that. We'll be using that. We'll be walking you through tools like SQL. We'll be walking you through tools like Excel, right? And so on, right? So there's a whole bunch of, for all of these different aspects, there are dozens and there are several software that you be given exposure to, right? So I'm sure ASAP has already shared that curriculum with you, right? You will see all of this tool like Python, R, Excel, visualization tools, right? And packages that are meant for doing statistical analysis, right? All of that will be shown to you.
Thank you, sir. Shibu T. Chavra has asked that, what are the opportunities available for experienced candidates? Where country or location will we get the best possible opportunity? I mean, he's trying to say which country we will get opportunity. In which country we will get an opportunity.
So the slide was actually supposed to answer that question, right? So sometime back, people were using analytics for sales and marketing, supply chain, finance and accounts. Those are the only ones which had numbers, right? Now there is no exception. Every division in a company requires analytics, which means we're not talking about India, we're not talking about US, we're not talking about UK. across globe, wherever business is there, right? Every business, medium-sized business to large businesses, they need analytics, which means across the globe, this is such an important thing, right? Definitely in India, because we are known to be some of the best when it comes to IT industry, software development, and all of it, right? So something to do with computer science, right? India is a big player in that landscape, isn't it? And then all the Western countries, right? So you definitely have scope across the globe, but some of you are planning to migrate to Canada, New Zealand, all of that has. So this is the reality. Data is the new oil, right? And within every organization, every division requires, it's not a company, particular division like finance using it. Every division requires data analysis because the volume is so high, data is generated so much, right? And nobody wants to leave their data unanalyzed, right? Because it's going to help them drive their business better, right? So which means every business, medium size or large, requires analytics for sure, right? Which means any business, any geography, right, has a big demand for analytics always, right? So that's an answer.
Okay, sir. We have another question from Vishwajit ES. I have a master's in physics and I am trying to get into data science or analytics. Apart from the course like ASAP, what could you help me? I have a strong background in Python.
Physics definitely is, so some 10, 15 years back, some of the people whom we used to go on to recruit are people with quants background, people with mechanical engineering background, people with computer science background, people with electronics background, right? So the electronics and computer science guys have some programming background. Mechanical engineering guys are heavily on the math side. People with mathematics, statistics, and physics are also good with quants, right? Some of the best of the AI and advanced analytics practitioners in the world, including companies like Google, have a physics background. So physics definitely is a nice degree. If you have a master's in physics, I think it's definitely an area that you might want to choose, right? But in terms of the course, there are so many courses out there. I know the ASAP course. ASAP course is one of the most advanced, right? And the government actually has. If you talk to ASAP folks, they would be able to say better than me, right? There's all these big IAS officer actually driving this program, right? You have all these IIT guys, IIT professors, right? With due respect to them, coming in and contributing and all of it, right? So one of the best of the course that is there, right? That is out there, right? So I think ASAP is one of the best courses. That I would really recommend that.
Okay, sir. Thank you. Another question is there any graphical user interface based tool available in this platform? Any GUI based tool?
There are a lot of tools that we will be exposing you to, which are graphical in nature, right? But there are also programming tools, right? And one of the things is a lot of what counter to what many of you think, right? We've taught a range of people with very, very different backgrounds, right? And many times when people have come to us as mechanical engineers, for example, right, they would come to us and say that I've never programmed, right? Seriously, right? And can I pick up programming? Yes, right? Or one of my best students actually is a law graduate, right? He's one of the best programmers I have ever seen, right? So what looks like painful programming experience, this question comes from somebody, I think, who has tried programming and then is a little apprehensive about that. Programming, it's just about how you've been taught or, how you try to learn, right? We'll try to make it easy for you, right? But there are definitely drag and drop tools that we're going to talk about for predictive analytics as well, right? But at the same time, right, I would really recommend that you get into programming as well, right? Not just drag and drop. get into programming as well. It's a lot more exciting, right? And you can do a lot more. The flexibility is a little less when you use a drag and drop tool, right? But if you could code, the power that you have in hand is much bigger, right? There are drag and drop tools in the course.
Okay, sir. Thank you. Another question is there any specification for the systems that we use to learn this business analytics course? Do we need to meet any specifications?
I think the regular laptops that you have at home, regular laptops and desktops should be sufficient. For some things that might be computationally very heavy, we will actually expose you to tools that are publicly available, and really that computation really doesn't happen on your machine, right? You could probably use a browser or so to access that, right? So a regular machine which, you know, some AMD or Intel, Intel Core i3, any of those regular machines are sufficient enough, right? With a reasonable amount of storage there, and fairly decent, at least upwards of 4 GB RAM. Recommended would be 8. But if you have 4 GB RAM and you're able to browse the internet fairly well, right? You are able to open tools like Excel. That is sufficient enough. We will really not want you to go on to invest additional amount, right, in buying laptops or desktop. What you have been using now, that is the best.
Okay, sir. Thank you. We have another question from Femi Jose. I'm an electronics engineer with Java background. Want to switch to data analytics path. So do I need to learn Python prior to joining this course, or it can be learned through the course?
It will be learned. You can learn it through the course. You can learn it through the course.
Okay, sir. Thank you. We have another question from Vinayak M. Can a fresh civil engineering graduate having beginner level knowledge in SQL and Tableau excel in the field of data analytics and business analytics?
Yeah, absolutely. This course is structured for people, not just engineers. This course, ASAP actually has a separate course for engineering graduates and so on, right? But then ASAP felt that some of these skills needs to be, these are very in-demand skills, right? Can that be extended beyond just engineers, right? Like people with masters in statistics or mathematics, people with physics background, right? People with economics background, actually, right? They use a lot of, quants, right? So all of these people, right, are so civil engineer definitely yes, right? Beyond that, all of these degrees that I mentioned, right, could be MCS, BCS, right? All of those people as well, MBA, right? All of these people are eligible. I really ask you to connect with ASAP team to ensure that your qualification is in line with what has been outlined by ASAP. But civil engineer, definitely yes.
Okay, sir. Thank you. We have one more question. Can you please suggest the best strategy of analytics for a company in agriculture mechanism industry?
So I think probably we'll have to bring that up during your course, right? So what would be taught here is majorly centered around data, right? That data can come from all sorts of sources. It could be from agriculture, right? Like yield, fertilizer input, rainfall, weather-related data, right? And all sorts of things, right? But the techniques that we are going to use are the same in automotive industry, in the advertising industry, in any other industry. So it is not, this course has been structured to a great extent to cater to any industry, right? And then there are some specializations like supply chain and stuff like that, right? Otherwise, you really, I really don't think there needs to be a specialized area of focus that you need to choose, right? Once you take this course, you will realize that there are like dozens and dozens of areas in agriculture that you could put to use, right? And this question is also related to what kind of agriculture are we talking about, right? Is it very technology driven, right? Are you talking about greenhouses, right? Are you talking about vertical farming? Are you having sensor data flowing in, right? Or are you using only government data, right? Are you talking about commodities commodities rates, right? And are you talking about weather, right? So it depends on what you would be using, right? And what type of, are you doing high tech farming? And if you're doing high tech farming, you have all the sensor data and all of that coming in, right? And but end of the day, right? Any of what we talked, right? Descriptive, predictive, prescriptive analytics, that is industry agnostic, right? Across industries, it can be applied.
Okay, sir. Thank you. I think we have one more question. Are data science and data analytics are same? Whether these are same?
They have a major overlap when people are talking about, and they're also jargons, right? Over the time, like I talked about MIS reporting at some point in time was called business intelligence, right? Data analytics nowadays is given a little broader phrase like data science, right? And so on. So they have a major overlap. Right? So in data science courses also, you'll see all of this descriptive analytics is a major part of data science courses.
Okay, sir. Thank you. I think we are done with all the questions, and we have exceeded our allowed time limit. Thank you, sir.
Thank you.
So to know more about the scale course business analytics and many other programs, and to know the detailed syllabus about these programs, please visit our website www.asapkerala.gov.in. Please note that the last date to apply for business analytics course is 21st November 2021. And tomorrow we will have another online session on Grab Your Dream Job in Software Testing by Srimati Aishwarya S. Please do attend and know more about various opportunities in software testing. Thank you so much.
Thank you, Arun. Thank you all. Thank you for your time.
Thank you all the participants. The webinar is over now.